All right, now most of the stuff you're going to see in this video, you actually learned from pre-calc. There were word problems that you did last year. But I just want to take some time to kind of show you where the formulas came from as well. So Timothy Tightwad puts $1,000 in a bank account. The account receives 3% annual interest compounded continuously. How much money does Timothy have at the end of 3 years? Well, hopefully you remember this equation from last year where we take how much? E to the rate, 0.03, and then time is 3, and we type that in our calculator and get the answer. But again, I just want to show you kind of where that came from. So let's say I'm going to change this instead of x to be a t to just be, to stay consistent with the formula. Let's say we say that dy dt is equal to 0.03 y, which goes to the fact that something is compounding by this percent interest based on what you had before. And you think about how y is changing, how your amount of money is changing. Well, you figure out 3% of what you have. If you had $1,000, you'd figure out 3% of that and say, okay, it's positive, so my rate of change is that much. It's $30 or and that's your rate. So now you have 1,030 after a year. Well, I'm going to get a y equals equation out of this differential. So I'm going to start by multiplying both sides by dt and divide both sides by y. So I've got 1 over y dy equals 0.03 dt. So we separate, integrate. Natural log of y equals 0.03 t plus a constant. Take e to both sides, and we end up with y equals e to the 0.03 t multiplied by e to a constant. Because remember, to get that addition in the exponent, we multiply. E to a constant is a new constant, so I can write this as constant e to the 0.03 t. And this is where that PERT equation comes from. Okay? Let me just remind you of one other formula before we are done. Put $1,000 in a bank account, it receives 3% annual interest compounded quarterly. How long does it take Timothy to double his money? Well, hopefully you remember this equation as well. So we have 1,000, 1 plus the rate divided by how often it compounds, and then raised to the 4t. And of course, we could set this equal to 2,000, and you could solve this with logs. But there's some calculus in this as well, okay? And it has to do with what happens as n gets larger and larger. So if instead of quarterly it were monthly or daily, well, essentially, this is kind of like PERT, right? But this, as n gets larger and larger, what's in parentheses here gets closer and closer to, when it's raised to this power, it gets closer and closer to e. So there's a limit here. There's a limit at work as n gets larger and larger, and of course a continuous growth, quarterly it's 4, monthly it'd be 12, daily it'd be 365. Continuously it would be infinity. Okay, so just something to think about for the future.